So this is going on page 53 when we're done. Okay. So we've already technically done section 113. This is 113 and 114 together, the modeling, and we're going to do some regression. Regression is not brand new to you. I know for sure that you do it in Algebra 1 and again in Algebra 2. So we're going to look at it maybe from, well, different aspect because you most likely did not do it on these calculators. But the idea of modeling is also called regression, and these will utilize the graphing calculator. So there's a difference between being allowed to use a calculator and being required to use a calculator. The way the AP exam is set up on the calculator sections, they're not there to help you add, subtract, multiply, and divide. You're allowed to use the calculator because you can't do what you need to do without the calculator, or at least you can't do it easily or accurately, okay, or efficiently. So basically, you have to know how to use the calculator on the calculator sections. So in Unit 1, we looked at linear and quadratic and cubic and quartic functions and rational functions. That's all we're looking at with regression right now. When we get into Unit 2, we talk about exponentials and logs and other things. Then we'll look at other types of regression, but we're just going to kind of do it a piece at a time, okay? So that's all you really need to know from this page. So go ahead and flip that over. Like I said, I'm going to walk you through this. All right, so we have the age in weeks and weight in kilograms. So we've got units here, very important, of 5 randomly selected babies from a particular pediatrician's office are listed in the table above. So I have T and W of T, and it gives me the units up there again. Okay, in terms of X and Y, which one of those two things is X? T. So this is X, this is Y. I'm going to label them because although we need to talk about this question and answer our stuff in terms of weeks and kilograms, our calculator only allows us to use X and Y. Okay, we don't get to put a T in there. So then we have a linear regression. So linear regression, so it says Y equals AX plus B. If it's a regression, let's think about what that means. That means if I plotted these points, I'm going to have like a scatter plot, right? My regression, I'm looking for the line of best fit, right? Those terms that you've heard before. So it's that same kind of thing. So the regression isn't necessarily going to hit all of those points. It might not actually hit any of the points, right? And so it is a prediction. To show that it's a prediction and not an actual just straight up equation that works, we put a little hat on Y. And we call it Y hat. Okay? And we have A plus BX. So if we look back over here in these instructions that I told you we're just going to skip because I'm going to walk you through it, it says right here, where does it say that? Right here. That when we do the linear regression, we can either choose MX plus B, which you're used to, right? Y equals MX plus B, or A plus BX. We're going to choose this one because that's where AP Stats is, and that's what we're kind of, I mean, I realize not all of you are going to take AP Stats, but this is more of a stats type thing. So if I do A plus BX, and this one right here, what is the slope in this form? What's the slope? B, and what's the y-intercept? A, right? It's just how it's set up. Remember, just like anything else, the actual letters don't really matter as long as you know where they are and what happens, okay? So that's the one we're going to choose just because. All right. Use the model of the data where Y hat is the predicted weight of the baby that is X weeks old, okay? And then we're going to write the equation of the linear model for these data. So again, I want you to stay with me, even if you're in AP Stats, because there's different ways to enter this data. There's different things to do with it. And right now we're starting off real basic, and we don't need all the extra stuff right now. So this may be the exact same thing you're doing in Stats. It may be different. I don't know. And in the end, if you get the same stuff, I guess it doesn't really matter. But so we're going to turn our calculators on. And when you turn it on, you get this, right? We want new, so 1 for new. And then do we want to save the unsaved document? The answer is no. When we first started using these calculators, I told you we almost always add a calculator, add a graph. This is where the almost comes in, because I'm not starting with that, right? I've got to put this table in here, and it's not called table, all right? What we're doing is we're adding lists and spreadsheet. I have a list of data, so you want to choose 4 right here. Okay? Then we should be here. Everybody with me? Okay. So then we need to title our lists. So here's where I would start entering my data, but I'm not doing that right now. We're not going to mess with the equals stuff right now. I want to get all the way up here so that I can, so I'm going to arrow up. I don't know why mine doesn't. I'm going to arrow up so I have my blue box around A. And we're going to title that X values. Now, you cannot, there's no space, you just X values all stuck together. So X values, pretend like it's a hashtag, you know, stick it all together. X values, and then hit enter. Then we're going to move over to B, and we're going to call that one Y values. Now, could I call it weeks and weight? Sure, you could do whatever, but we're just going to be simple here. Okay, X values, Y values. Okay, good. So now I'm going to go back to column A and go down to the first cell right here, and I'm going to enter my data. So all of this gets entered into X, all of this gets entered into Y. So let's see, I look at mine. I'm going to have 4, enter, 5, enter, 6, enter, 8, enter, 12. Once you get all your X values in there, then arrow to the right, go back up to the first for your Y values, and get that information. Some things about this calculator are very intuitive. Some things are not, right? There's some things that, you know. Everybody with me here? We're all good. Good to move on. Okay, so now I want the calculator to do something with this data for me. I want it to come up with a regression equation. So to find where all my choices are, just like all your choices at a restaurant, they're in menu. Okay. Now, we don't want to insert anything. We already have our data in there. We're doing some statistical stuff. So it's 4 for statistics. And I want it to calculate something for me. So statistics and then stat calculations. Then I get a whole bunch of choices. Which one are we picking? 4, right? 4. And then we're here. Okay, everybody here? Menu and 4, 1 for stat calculations, and then, yeah, I know. If you accidentally hit one thing, then it's fine. That's why I keep asking. All right, so our X list, we called that X values, right? So you can use this little hand key here, hit that, this pops down, you choose X values, then arrow down to Y list, and choose Y values. Okay, X values in X, Y values in Y, yes. I think because you're clicked in that, like it's thinking you want to put it in there. So let's escape out of that. Now let's try it. Menu 4, 1, 4. There we go. Yeah. So well, I'll show you what happened when we get back over there. But all right, everybody else here. So now this next part is very important that we don't mess with anything. We're going to save this regression equation to F1. So it's going to give us an equation. We're going to be able to figure it out and write it down, but it's also going to be stored in F1. So that should populate automatically. We're not messing with it. Okay? Everybody else good? Yes. No, it was just already there. Like when you type it in, I don't know why it's there. Well, it's because it's the name of something. Yeah, the little it's not an asterisk. That's what I want to say too. The apostrophe. Thank you. My God, the thingy up there. The apostrophe just automatically shows up. Okay. Are we good? Okay. So then, right now we can just hit enter. Now you get your table back. Okay. So the reason she was having trouble over there is because when she was trying to hit all those buttons, she was actually clicked in a cell, and it thought she was trying to put something in the cell. So if that happens, we just hit escape, and then we were able to actually use the menu. So that could happen to anybody. All right. So now it's telling me that I have this regression equation. It's a plus bx. It's reminding me what form we put it in. It's giving me a, it's giving me b, it's also giving me r squared, r, residuals, all this stuff. We don't care about that right now. We just care about this little equation. So I can come back over here, and now I'm going to write my equation. It's underneath all those little boxes that just basically show you what we just did. My regression model is y hat equals then it is 3.545 plus 0.185x, right? And it's y hat because it's an approximation, or it's predicted, rather. We all okay with that? Yes, sir. Why did you do it twice? So because you don't have the first, you don't have, yeah, you got to add those. You can add them at the bottom, but you got to add them. Okay. Everybody good? Everybody else good? All right, now, this is in terms of x and y. Our problem situation is not x and y, right? It's t and w of t. So in order for me to put this in terms of what I need this in, this is w of t is equal to 3.5 plus 0.185 t. Now, it is very important that you and anybody looking at your paper can tell the difference between a plus sign and a t, because we're going to use t a lot, okay? Until I've been making my t's a lot. I have a math degree, so when that became really important, I didn't used to write my t's like that. I used to write my t's like that, but then I had to change because I was using it so much and it was confusing. Now, here's the whole thing here. I'm saying that my equation for w of t is this, but that is still a prediction, right? I just put it in terms of what we have. So to show that it's a prediction, we put the hat over the whole thing. Okay. Everybody with me? Any questions? Those of you that were by, did you get caught up on whatever? Did you get it? Okay. All right, so now it says on part B, using the linear model from part A, so what we have right here, what is the predicted weight in kilograms of a baby that is 10 weeks old? So what I want is W of 10 hat, right? That's what I'm looking for. Now there's a little tip here. It says you can quickly find values of functions that are saved in F1 from the calculator page. Now remember, we told it to save it in F1. Remember when that popped up? Like it was already there, but it said save that in F1. Right? Well, when we opened this, we did not say, hey, also open a calculator page. I can see right here, this is the only page I have open. I didn't necessarily know if I needed a calculator page. So that's okay, we can add one. Do not hit the home button and say, no, you don't want to save anything, because we're not starting over. I'm just adding to what I have. So if I want to add a page, there's this dock key right here. See blue above it, it says plus page. So I'm going to do Control, dock, and I want to add a calculator. So what I'm going to do in my calculator, because we saved this is saved in F1, right? So on the calculator, now this isn't something you have to write for your answer. I would write it on your notes. You can write it for yourself. What we're going to find is F1 of 10, because that is stored F1. We can't call it W of t. So in the calculator, I'm going to literally type F1 of 10 and hit enter. And it gives me my answer. Everybody okay with all that? Now, that means that my predicted value at 10 weeks is 5.395. 5.395 what? Weeks? Pounds? Kilograms. So at 10 weeks, it's predicted that that's how much the baby would weigh. Do all babies weigh the same at 10 weeks? No. I mean, this is a prediction based on, just what we have from this one pediatrician. Okay, everybody okay with that? What questions you got? All right, so then C says the weight of a sixth baby is 5.3 kilograms. Use the model from part A. What is the age in weeks of the baby? So it is telling me that W of t, the weight is equal to 5.3. Does that mean I take 5.3 and substitute it in for t? No, it's giving me the weight, I want the time, okay? So if it's giving me that, basically it gave me the y value. Now I can set this 5.3 equal to this, and I can solve it by hand, right? Can totally do that. Or we can do it on the calculator. I say we do it on the calculator, right? So if I go over here, I can't do it from this screen. I need to do it from a graph. Well, we didn't add a graph, but can we add a graph at this point? Yes. So I'm going to do Control, Doc, add a page again. This time I'm going to add a graph. And you see how when you do that, it starts you at F2, but you don't see anything, right? So if you're here, now arrow up, we told it to save it in F1. It saved it in F1 even though we didn't have a graph open. Okay? You with me on that? So here, now that I have it, I can just hit enter. That is the line that we found that's our prediction. Now, does that give me my answer? No. Okay? And if, I need to know, this goes from, my window goes from 0 to 6.67, so 5.3 is up here somewhere. But I need to know where 5.3 intersects this line, so I need to graph that. This right here is basically saying to me, y equals 5.3. So that's what I'm going to put in my calculator. I need to put it in as a graph. How do I get back up to where I can type a function in? What do I hit? Tab. Okay. Tab. So now I'm at F2, and I don't know why mine does this. I don't think yours will. And we're going to type in 5.3. Boom. Now, I know that this is a linear regression. So I could change my window, but I don't need to. Is this going to intersect at more than one spot? No, because it's two lines, right? If it wasn't linear, I might want to be able to see the rest of the graph to see if it intersects again or whatever, but I don't care. And even though it's at the edge here, I can see right where the intersection point is, right? I'm trying to point, but you with me on that? I can see it. You could, change it if you want to, but we're not going to bother. So I want to know where those two lines intersect. How do I do that? What do I hit first? Menu. That's where my choices are. What am I trying to do? Analyze the graph. And then what am I looking for? Intersection. Okay. And then remember, if your dotted line is not to the left of where the intersection is, you use this thing right here to move it. I just can't do that on my board. If yours popped up where mine did, then you can just hit that key right there with the little hand. And then it says upper bound. So then you use that little trackpad to move it. Again, I can't really do it on this board because it doesn't like it. But you do that, it'll kind of highlight it, get it on the other side of it, which I know is close to the edge, but you can get it on the other side of it. And then it'll give you your answer right there. Everybody okay with all that? All right, so then I can come back over here, and my answer is T equals 9.4864 weeks. Any questions about that? Good deal. We all good? We are going to, at some point, go back and look at the R values, plot the R values, do all kinds of things, but we'll get there later. We're just baby stepping into this right now. All right, we all good? Okay, so then down here, it says selecting an appropriate model type, which is something we talked about the other day, and this kind of says the same thing, so we're not going to spend tons of time on it. But so sometimes you're told, use a cubic regression model, blah, blah, blah. If you're told, that's great. You know exactly what to do. You don't have to worry about it. But sometimes you have to determine it either based on the problem situation or based on a table of data. But we're also going to look at it like, what if we don't even have any data? So our linear models, and notice these both stay roughly, because this isn't a hard and fast rule, because lots of things could be linear, lots of things could be quadratic. But linear models, roughly constant rates of change. Usually when you read that, you can kind of tell that it's supposed to be linear based on what's happening. Our quadratic models, roughly linear rates of change. So it's not a constant rate of change, but it's changing at a constant rate, right? Or roughly symmetric with a single maximum or minimum. Meaning you can look at your Y values and you can see that they're coming up, go back down. Or they went down and they're coming back up, and you can kind of picture that you only have one maximum or minimum, and it's quadratic-like, right? Or involving area. Okay? okay, which is kind of what we looked at the other day. Cubic models, context involving volume. That's really how you're going to be able to tell right now is that it's a volume type problem, or you're straight up told use the cubic model. Okay, everybody okay with all that so far? All right, so let's, I need to give you the second piece of paper here to put this, so we can get this started. We'll have to finish tomorrow, obviously, but get started. There we go. Okay, so this is also going on page 53. It says for each of the following situations, determine whether a linear, quadratic, or cubic model would be the most appropriate. So again, that's really all we've talked about as far as looking at graphs and stuff. We will get back to this and also look at exponential and other ones, but we haven't talked about those functions yet. That's why they're not even an option. Okay. All right, so we have balloons are filled with water in preparation for an epic water balloon battle. Each water balloon is roughly spherical. Most of the times we kind of like pretend that a balloon is a sphere so that we can do things. The radius of each water balloon is measured relative to the amount of water it holds. Okay? In what way do we normally measure an amount of water? With volume, right? So would this make sense that this is a volume type? This question is involving volume, yes? So I would say that, would this be linear, quadratic, or cubic? Cubic. So we can say it's cubic because it involves volume. Most of the time, you're going to have data to look at, too, in case the words are weird or whatever. All right, so then Totino's pizzas are on sale at a local grocery store. The price of one pizza varies between $1.99 and $2.19, depending on the variety. The total number of Totino's pizzas are counted relative to the total price of the purchase. What do you think about that? Linear, right? So I'd say linear. And we could say that price depends on variety. Well, something like that. All right, so then we have a sprinkler placed in a yard to water the grass. The sprinkler rotates in a circular pattern and waters all the grass between the sprinkler head and the furthest distance it reaches. The radius of the circular path is measured relative to the area watered by the sprinkler. What do you think? Quadratic, because it says area right there, right? Well, you can hopefully picture that. So this is quadratic. And our reason here could be because it involves area. Any questions at this point? All right, then we are going to stop here today. We will pick up tomorrow on this, so make sure that you bring your papers back, your calculators back if you're using your own. If you're not, if you have mine, please make sure they get put back.